This is a second video of 3 involving Competency 16 practice questions. Number 8. A 7-sided die is rolled 3 times. What is the probability of rolling an odd with 2 of the 3 rolls? Well, we are working with probability, but it's very basic, part over total. So we know that we have a 7-sided die and we have 3 events. So the first event has a total of 7, and odd numbers would be 1, 3, 5, and 7. That's 4 out of the 7. We need to multiply. And the next event is also about odd numbers. So that is 4 out of 7. However, the last event has 2, 4, and 6. That is 3 out of the 7. We simply need to multiply, and we don't need to use parentheses. We should be okay with our order of operations. So 4 divided by 7 times 4 divided by 7 times 3 divided by 7. Enter. We need a fraction, so math, enter. 48 out of 343. Number 9. Which one of the following experiments has the least number of outcomes in its sample? That should say sample space. Let me add that real quick. Okay. All right. Let's look. A. Drawing 2 cards from a deck one at a time with replacing. That will be where we have 2 cards in a deck. So we can, 52 cards in a deck. So that will be 52 squared. Enter. That's 2,704. B, we are drawing 2 cards from a deck one at a time without drawing. That changes it very slightly. That will be 52 cards. Then we take 1 out. Then that's times 51. Enter. That's 2,652. Well, that one is less, so we can mark out A. Let's see if C is less. Tossing an ordinary coin 13 times. Well, the probability or total outcomes of any coin is 2. If we roll it 13 times, toss it 13 times, that will be to the 13th power. So press your caret up 13, enter. 8,192. That is more. We're looking for the least number of outcomes. C is greater than B, so that one's out. Let's look at D. Rolling an ordinary die 5 times. Well, the probability of any die, an ordinary die, is 6. So 5 times means caret up to the to the 5th power, enter, and that is 7,776. Still more than B, so B is our final answer. Number 10, a penny, nickel, and a dime are tossed twice. Let F be the event of all outcomes in which the penny and the nickel land on tails. How many outcomes does F contain? Well, that would be the penny landing on tails and the nickel landing on tails. That's simply 2 outcomes. Okay, they're not asking about probability. That's kind of a trick question. Okay. Let's move on. A six-sided, well, it's number 11. A six-sided die is rolled 3 times. If the first 2 rolls are odd numbers, which is a true statement about the third roll? Okay, we have a six-sided die. That's an ordinary die, meaning the total outcomes for each roll is 6. Okay, we have the first 2 odd numbers. Okay, well, there are 3 odd numbers, so that's 3 out of 6 for the first roll. Same for the second roll. What is true? The first 2 rolls. Well, what is true is A, it has an equal probability to be an odd number. Yeah, it could be odd again. It has a less likely number to be, no. The die doesn't change as you roll it. It stays the same no matter what you do. It could be 3 odd or even 3 even also. So I disagree with that. It has more likely to be an odd number. No, it doesn't change. It'll be the same. It is more likely to be an even. Well, no, that's not true either because there's 3 even, 2, 4, 6. So A is our conclusion. Number 12. An ordinary die is rolled twice. What is the probability that the first roll will land on a number less than 3 and the second roll will land on a number greater than 4? Well, less than 3 is numbers 1 and 2. So that is 2 out of 6 since we're using an ordinary die. So that's 2 out of 6. And a greater number than 4 would be 5 and 6. That's also 2 out of 6, which equals 4 out of 36. If you simplify that, you will get 1 out of 9, which is option C. We can just put that in the calculator. We don't need to use parentheses. So we have 2 divided by 6 times 2 divided by 6. Enter. Of course, we need a fraction. So math, enter, 1/9. Number 13. If you draw 2 cards from a standard deck, one at a time with replacement, what is the probability that the first card is a black king and the second, there's your word, and the second card is any 10? Okay, out of any deck, you will have 1 black spade and 1 black club. Okay, and then there are 4 number cards that are a 10. We have 2 black kings. So we have 2 out of 52. And we did read with replacement. So that's your first event. Now, second event, we still have 52 cards. However, we have 4 total. Now, put that in the calculator. We don't need our parentheses because we are dividing and multiplying. Okay, 2 divided by 52. Oh, yeah. Times 4 divided by 52. Enter. That gives us, okay, that gives us a pretty extensive decimal. Let's see if we can get a fraction out of that. Enter. Math, enter. Yes, we can. That is option B. The reason I said that is sometimes, every once in a while, like we've had before, we'll run into the limit of the calculator, but we're okay. That decimal wasn't actually too bad. Now, number 14. Which of the following implies events X and Y must be mutually exclusive? In this situation, let's get rid of these remnants. In this situation, we need to know the properties or understand what mutually exclusive means. This means that the events X and Y will not occur at the same time. So, whatever we're dealing with, we're going to add the event of X to the event of Y, but we will not be subtracting the events they have in common that we multiply together. So that means that in the event of X, we don't have. It's impossible to have Y, and meaning you can't multiply them together and get a value. Okay, let's move on and kind of see what this means. Okay, well, in my explanation I gave you, I didn't say anything about these two events being equal. They don't necessarily have to be when we add them together, so that isn't going to work. Now, here's adding the two events together and they equal 1. Well, that really implies you don't have to subtract anything out. But I'm not going to necessarily believe that. I think that that means you're subtracting out. Well, you just don't have to subtract out. I don't think that applies anything actually. It's it's a different concept that we'll discuss at another time. Okay, the next one says the probability of X is actually equal to if we have X, then Y. Mm, that's true in some cases, but not in I mean, this isn't relevant for us right now, so I wouldn't say that. Now let's look at this next. It has to be the last one. Let's hope. Okay, in the event that we have X, then Y. So we have X and Y dependent of each other. This is what this means. We have a dependency. But this dependency is equal to 0. This means if we have X, then we do not have Y. That makes sense. They're mutually exclusive. Like above on number 13, let's look at number 13. Getting a black king in no way has anything to do with the number 10 being drawn. And this is why we're simply, well, we have the word and too, and we multiply them together, and that's all we need to do. So in this case, these are dependent, so they're like linked together. We are going to not replace. So in order to have X, and we're not replacing the card, we must have Y. So it has a value. Well, this is saying it doesn't have a value. So that is correct.